Talk about today is motion in 2 dimensions. So this is going to be things moving both horizontally and vertically, or north, south, and east and west. So we did this vector demonstration. We can't redo it on the video, but I think most of you understood what it was. A person walks 25 meters east, then 25 meters north. What is the total displacement? So because displacement is a vector, we need to include angle and direction. So how we're going to figure out what so we've got 25 meters east and 25 meters north, obviously drawn excellently. So how can we figure out, make that red actually, that side and that angle? So to figure out that side, we're going to say question mark squared equals 25 squared plus 25 squared. And what's the length of that side? What was that? 35.4 meters. And our angle, we'll call that theta, is going to be 45 because they're both the same size, right? Or the way to do that would be inverse tangent when we get to that. And what's that angle measured from? That's going to be 45 degrees northeast, 45 degrees. The way we have it measured here, 45 degrees north of east. So we have east this way. We're going 45 degrees toward north. North of what east would be. So if it was measured the other way, if we started up here, do the blue, it would be east of north if we measured it that direction. Does that make sense, everybody? Right. Next question. A person walks 35 meters at an angle of 38 degrees north of east. How far east did the person walk? So they go 35 meters, and our angle there is 38 degrees. So how far east did the person walk? So that's what we want to figure out first. Say question mark east. So how can we find that side? Is it going to be sine, cosine, or tangent? Cosine. So it's going to be cosine 38 equals, what's cosine 38 equal? Adjacent over hypotenuse, so let's say that 80j by p. So that equals question mark in the east divided by 35. So how far did he walk east? 33.43. Make sure your calculators are in degree modes, guys. Alright. Alright, so 27.6 meters east. Alright, so for the north direction, what are we going to use, sine, cosine, or tangent? Yep. So it's going to be sine 38 equals opposite over hypotenuse equals, so question mark north divided by 35. And what do we get for how far north he went? 21.5 meters north. Any questions about it? Number 3, a helicopter is traveling at a constant velocity of 25 meters per second, angle of 15 degrees above the horizontal. How fast is it moving horizontally? So draw our helicopter, 25 meters per second. There's the ground. That angle is 15 degrees. So how are we going to find how fast it's moving horizontally? We're looking for like the ground side of that velocity vector. Cosine, cosine, as Garrett would say. So cosine 15 equals adjacent which is what we're looking for, over hypotenuse, which is 25 meters per second. And how fast it's moving horizontally is going to be what? 24.1 meters per second. You could say horizontally if you wanted to at the end of that, since that's for velocity. Any questions on that one? All right. Helicopter traveling at a constant velocity of 25 meters per second, angle 15 degrees above the horizontal. How far does it go horizontally in 5 seconds? We said the horizontal velocity was 24.1, right? We'll call that Vx equals 24.1 meters per second. So we can use Vx equals delta x over t. So then we get 24.1 equals delta x over 5 seconds. And what do we get for delta x? 120.7. Alright. Depending on how you're rounding, we'll say the answer there. Alright, any questions on that one? So, projectiles. This is what we're going to spend a lot of time doing in here. Projectile is something that is in free fall, no air resistance, and has horizontal and vertical components to its motion. So, one thing I want you guys to notice here, if you had like a gravity-free path of this cannonball, it goes the same distance every second. So, the vertical or the horizontal part of its motion not affected by gravity. Vertical part of its motion is affected by gravity. So if you shoot it going this way at 10 meters per second, it's going to continue to travel at 10 meters per second horizontally until it hits the ground. Does that make sense to everybody? So what we're going to start with tomorrow when you do problems is projectiles launched horizontally. Its initial, and when you're launched horizontally, the initial vertical velocity is 0 meters per second. I added all those exclamation points because it's something people forget a lot. I'll underline them too. Alright, and the horizontal velocity is constant, so there's no acceleration in the horizontal direction as long as you're in free fall. I am going to give you problems where like there is acceleration in the horizontal direction because I'm mean, but for the most part, unless you're given a horizontal acceleration, there is no horizontal acceleration. And so how fast a projectile is moving horizontally does not affect how fast it's moving vertically. Those assumptions make sense. They're not always true if you were like launching an airplane, like a model airplane or something like that that generated lift. That last one's not going to be true. How fast it's moving horizontally then would affect how fast it's moving vertically. But if we're talking about like a bullet or something like that, these are very true for the most part. So a bullet is fired from a gun, and an identical bullet is dropped from the same height at the exact same time. Which bullet hits the ground first? Same time. Because how fast it's moving vertically does not affect how fast it moves horizontally, or how fast horizontally does not affect how fast it moves vertically, they both drop at the same rate and hit the ground at the same time. One is a very further distance away, but they both hit the ground at the same time. They did it on Mythbusters once, and they showed that it was true within like, well, within experimental error. The projectile is launched horizontally with an initial velocity of 5 meters per second. What is the initial velocity? Vertical velocity? 0. Oops. These are usually not very hard. The projectile is launched horizontally with a velocity of 5 meters per second. If it takes the object 3 seconds to hit the ground, how far horizontally did the object travel? $15 meters, right? So it's just 5 meters per second times the time. The projectile is launched at angles. This is where it starts to get a little trickier. So for a projectile launched at an angle, it's going to look something like this. So it's going to have some initial velocity, which we're going to label just v, is the initial velocity of that. It's going to have a horizontal component, which we're going to label vx, and an initial vertical component, which we're going to actually call this vo. which you're going to label VOY. And it's going to be launched at some angle theta. Does that make sense? So usually what you're going to be given is you're going to be given VO and theta, and the first thing you'll have to do is find Vx and VOY using sine and cosine. Yep. So this is the initial velocity in the vertical direction. This is the velocity in the horizontal direction, which stays the same. Alright, so this is kind of another diagram of how projectiles launched at angles works. You get the nice little parabola looking thing there. So if you launch it up, it will initially start going up and then change direction and go down at some point. But the horizontal part, if it was gravity free or if it's not gravity free, it goes the same distance horizontally each second. Alright, first question here. Stone is thrown upward at an angle. What happens to the horizontal x component of its velocity as it falls? Stays the same. What happens to the vertical y component of its fall as it falls? We're just going to say changes by 9.8 meters per second every second. We can say negative 9.8. Alright. Alright, number 2 is projectiles launched at an angle of 60 degrees above the horizontal with a velocity of 25 meters per second. What are the horizontal and vertical components of the velocity? So it was launched 25 meters per second. We've got 60 degrees. So we've got looking for Vx and VOY. So Vx is going to be sine or cosine. It's going to be cosine 60 degrees times 25 meters per second. And what do you get for Vx? 12.5 meters per second. So that's how fast it's moving horizontally. VOY is going to be sine 60 times 25 meters per second. And what's that equal? 21.7 meters per second. Any questions on that one? All right. Number 3, a projectile is launched at an angle and has an x component to its velocity of 21 meters per second. If the projectile is in the air for 3 seconds, how far horizontally does it travel? 63 meters. It's moving at 21 meters per second horizontally. So after 3 seconds, it'll have moved 63 meters horizontally. 21 times 3. Number 4. Projectile is launched at an angle and has a vertical component to its velocity of 24 meters per second. How long is it in the air for? Okay, so this gets a little trickier here. Alright, still not too bad though. So we've got our triangle. We've got all of this is our vertical component is 24 meters per second. So that's VOY. So now we're going to use this equation to solve for time. So just like we said in the last part, the time it takes to get to the top of its path is equal to the time it takes to get to the bottom. So that's part 1, part 2, T1 would equal T2. Does that make sense to everybody? So all we do is we say, what's our final vertical velocity up here going to be at that point? 0. So vertical velocity at the highest point is still 0. So we're going to say final velocity in the y direction equals initial velocity in the y direction plus gravity times time. So we get 0 equals VOY, which is 24, and that's positive 24 since it's going up initially, plus negative 9.8 times time. And what is our time to get to the highest point? 2.45 seconds. So now we want to multiply that by 2. And so our total time in the air is going to be 4.9 seconds. Any questions about that one? That's assuming it's on level ground and not like jumping off a cliff or anything like that. Number 5, projectile is launched at an angle of 23 degrees and has a horizontal component to its velocity of 65 meters per second. Projectile is in the air for 4.5 seconds. How far horizontally did it travel? So this one we're going to need to do some. Do we skip 4? 65 meters per second. And we've got 23 degrees. Oh. Oh. That's pretty easy then. 65 meters per second on the bottom. So how far horizontally does it travel? We don't need to use the 23 at all. What is it? Alright, so it goes 292.5 meters horizontally because it's moving at 65 meters per second for 4.5 seconds. So 4.5 times 65 is 292.5. Our equations for this stuff in the x and the y direction. We're going to have equations in both x and y. This is the kind of the standard ones. If there's acceleration for some reason in the x direction, you're going to have the acceleration equations in the x direction. So for normally it's going to look like this. It's going to be delta x equals vx over t. And we're going to have delta y equals 1/2 times v oy plus v fy times t. Delta y equals VOY t plus 1/2 GT squared. VFY equals VOY plus GT. And VFY squared equals VOY squared plus 2G delta y. Those look familiar to everybody?
Sometimes you're going to be asked for the final velocity, like the overall velocity of any projectile, or the velocity of a projectile at a given point, or the speed of a projectile at a given point. What that's asking for is if, let's say, you're launched off a cliff, and you're going like that, it's asking for the overall speed at some point along that. So it's going to be asking for like the how fast it's moving and the angle. So what you're going to have there is you're going to have another triangle. And you're going to have Vx on bottom, and instead of Voy on the side, it's going to be Vfy on the side. And what you're looking for is just Vf. And usually, if it's asking for an angle, it's asking for that one, the angle between that and the ground. That's a terrible theta, isn't it? You guys can understand how that would work? So let's say we wanted to figure out, we threw you horizontally off a cliff, Garrett, wanted to figure out how fast you hit the ground. You're going to have to incorporate both how fast you're moving vertically toward the ground and how fast you're moving horizontally. So to figure out overall how fast you hit the ground, which is going to be important to you for how much damage is done to your body, you're going to have to do the Pythagorean theorem to find the overall final velocity. Does that make sense?
Why isn't theta the other angle? It's just what we use normally. We usually say, we're going to say, with what angle does it hit the ground at? Usually we're talking about something hitting the ground, so you're going to measure the angle from the ground.
Okay. So basically, like, what angle did they throw it at?
This is like the final part of it, not the initial part of it. So you're not going to see anything about being thrown or anything like that. See, this is something that's kind of intuitive for most people. So it's useful when you're thinking about two objects moving instead of just one object moving. So the easiest way to explain this is through examples. So we're just going to go through some examples and it'll probably make sense to everybody. in a car north at 60 kilometers per hour, and your friend is traveling toward you going south at 60 kilometers per hour. How fast are you approaching your friend? 120 kilometers per hour. All right. So now you're behind your friend in a car trying to catch them. You're traveling at north at 65 kilometers per hour, and your friend is ahead of you traveling north at 65 kilometers per hour. How fast are you traveling relative to your friend? Oops. 5 kilometers per hour. You're trying to catch the evil monkey that lives in your closet. Your monkey is running north at 2.5 kilometers per hour, and you're behind him running at 2 kilometers per hour. How fast are you moving relative to the monkey? Negative 0.5 kilometers per hour. And is the distance between you and the monkey getting larger or smaller? Larger. Last slide here. You're in a boat paddling at a rate of 4 meters per second in still water. If you are paddling upstream against a current in a 6 meter per second current, what is your velocity relative to the shore? So it's going to be negative 2 meters per second because you're going backwards. Does that make sense?